Let's look at the last question. Let's look at the last question on limiting factor analysis. Now, this question is a bit tricky, and it's the last question because I want you to look at the various ways by which they can set the questions. Okay, let's look at the question. A company manufactures and sells two products, product X and product Y. The two products are manufactured on the same machines. There are two types of machines. The time required to make each unit of product is as follows. So you have machine type 1, and on machine type 1, we produce X on it. We use 10 minutes per minute. Then when we finish that 10 minutes, we use 6 minutes per unit to produce Y on the same machine type 1. The same applies to machine type 2. So we will manufacture X on it and we will manufacture Y on it. And that is what this statement means. The two products are manufactured on the same machine. Sales demand each year is for 12,000 units of product X and 15,000 units of product Y. Okay, the contribution per unit is $7 for product X and $5 for product Y. There's a limit to machine capacity. Now, if we say there's a limit to machine capacity, now let's say you have two types of machine, A, B. Machine A cannot be the same as B in terms of efficiency because of maybe depreciation. So if you have depreciation, then machine B can be more efficient than machine A, or machine A can be more efficient than machine B. So the question is saying that machine there is a limit to machine capacity. However, and in each year there are only 3,000 hours of machine 1, that's machine type 1 time available, and 4,200 hours of machine type 2 time available. Okay, so which of these machine types is the limiting factor? Machine type 1 or machine type 2 is the limiting factor. So we need to find out. So in order to find out, you have to look at your machine type 1 and your machine type 2. Great. Now, the question said how many hours are available. So you realize that the available hours for machine type 1 is 3,000, and for machine type 2 is 4,200. Great. Now, if we want to produce 12,000 units of X and 15,000 units of Y, how many hours do we need on machine type 1, and how many hours do we need on machine type 2? So we are going to work the needed hours. Okay, so if we want the needed hours, then we have to look at for machine type 1, we have product X and we have product Y. Now, if we want to produce 12,000 units of product X, how many hours will be needed on machine type 1? So here we have 12,000 units. And here, when it comes to machine type 1, 10 minutes is used per unit. So we multiply by 10. That is 10 minutes. Now, product Y, we have to produce 15,000 units to meet the sales demand. So 15,000 units times how many minutes? 6 minutes per unit on type 1. So 6 minutes. Great. Now, let me put this one here so that it will align very well. So here is 3,000 and 4,200. Okay, 3,000, 4,200. Now, when you multiply 12,000 by 10 minutes, you are going to get 120,000 units, 120,000 minutes. And 15,000 times 6, 15,000 times 6 is going to give us 90,000 minutes. But remember, this one is in hours. The 3,000 is in hours as well as the 4,200. But here, what we have computed is in minutes. So we have to add these two to get 21,000, 210,000 minutes. And we need to convert 210,000 minutes into hours before we can compare. So conversion. So here will be 210,000 divided by 60 minutes because 60 minutes make 1 hour. So 210,000 divided by 60, giving us 3,500. Now, we are comparing this to this. So here, you realize that for machine type 1, the computation is that we have available of hours of 3,000, but we need 3,500. You need 3,500 to produce X and Y, but what you have available is 3,000. So here there is shortage of 500. Why shortage? Why do you think there is a shortage? There is a shortage because if you want to produce all the 12,000 units and 15,000 units, you will need or you have to have 3,500 in order to meet that demand. 3,500 hours. However, the question says that what we have available or what you can actually get in producing that X and Y is 3,000. So there's shortage of 500. Now let's go to the computation. So we use the same approach. 12,000 units of X times, come here, 5 minutes. So 5 minutes. Then we have 15,000 units of times 12. So here 12 minutes. Now let's look at here. When you multiply 12,000 by 5, 12,000 by 5, you are going to get 60,000 minutes. Then 15,000 by 12, you are going to get 180,000 minutes. Now, let's add 180,000 to 180,000 to 60,000, giving us 240,000 minutes. Now, let's do the conversion. So the conversion here is going to 240,000 divided by 60 minutes. and that is going to give us 4,000. So here we are going to get, let me write 4,000 here. Forgive my arrangement. Now we are going to compare this 4,200 to this one. Now, oh, sorry, it is 4,000. Sorry, 4,000. It is 4,000, not 4,200. Great. Now, let's look at here. To produce product X, okay, to produce product X and Y using machine type 2, we need 4,000 hours. 4,000 hours. However, when we check, the available hours is 4,200. So you have more available hours than what you need. Therefore, there is excess. Excess of what? 200. There is excess of there's excess of 200 hours. There's excess of 200 hours. Okay, now don't forget, limiting factor is looking at the resource that is in short supply. So here, the limited resource is machine limiting factor is machine type 1 because there is shortage. Okay, great. If you understand this, then let's go and look at the production schedule. Let's look at the production schedule. So, production schedule. Okay, so we'll start with product, then uh, time needed, and time left. Okay. Oh, sorry. So before we do the production schedule, we have to look at the rankings. And here we have to look at the contribution. We have to maximize the contribution per unit of limited factor, right? Okay. So here, when you look at here, you ask yourself for product A and sorry, product X and product Y, what is the contribution per unit? Contribution per unit for X is 7, for X is 7, and for Y is 5. Now, what is the limiting factor per hour? So here, when you look at here, we have ascertained that the machine type 1 is the limiting factor. Okay, so if machine type 1 is the limiting factor, then we need 10 minutes per unit on X and 6 minutes per unit on Y. Now, here we cannot express it in units because the time available is in hours. So we need to convert this into hours. So, so for X is going to be 10 minutes divided by 60. And 10 minutes divided by 60, 10 divided by 60 is how much? 10 divided by 60 is 0.11, let's say 167. Let's make three decimal places. And for y is going to be 6 divided by 60, giving us 0.1. Okay, so 0.167 and 0.1. Now look at here, contribution per limiting factor. So we will divide 7 by 16.167. 7 divided by 0.167. 7 divided by 0.1167. That will give us, say, 40, that's 42.9. 42.9. Then 5 divided by 0.1. That will give us 50. Okay, so we have to rank. Let me write here. Uh, okay, so rank. This one is the first. This one is the second. Is the first because that is the highest contribution per unit, which is 50, which is higher than 42.9. Okay, now let's use let's look at the production schedule. So this one is saying that we have to start with Y first. Now for Y, we need to produce 15,000 units. So 15,000 units times, what is the hour per unit? The hours that we calculated is 0.167, as in here and here, which we transferred to this part. So 0.167. Now 15,000 times 0.167 is 25 is equals to 2505, right? 2505. But they are saying that the hours available on machine type 1, which is the limiting resource here, given in the question, is 3,000. So the time that will be left is 3,000 minus 2505. So 3,000. So here we are going to get 495. Great. Now this 495 is what we are going to use in producing the rest of product X or machine type. So here hours. So machine type 1, there's only available hours of 495. What do we do now? What do we do now? So since we have 495, we need to use it to produce the rest. So here you realize that uh, we can only use the 495 here, and the machine hours per unit of oh, sorry. I have made a mistake. Let me go back and reverse it. Sorry, I've made a mistake. I have seen it fast. So here 15,000 units is Y. Y is 0.1. The hours unit is 0.1, not 0.17, because here is 0.1. So here 15,000 times 0.1. That will give us 1,500. That will give us 1,500 hours. Okay. Now, there's available time of 3,000 hours, according to the question here, 3,000 hours. So if we have used 1,500 hours, then we'll be left with 1,500. Now, that 1,500 is what we are going to use in producing X. Now, look, if we want to produce all the units of X, so all the units of X is 12,000 units. X is 12,000 units. And according to the question, per unit is 0.167. So if we want to produce all the 12,000 units, 12,000 times 0.167, that will give us 2,004 hours. So we need 2,004 hours. Produce all the 12,000 units. But we don't have 2004, we only have 1,500 hours. So we need to use the 1,500 to produce the rest for X. So here, 1,500 hours. Now per unit is 0.167. So we divide 1,500 by 0.167, giving us 8982 units. So what this means is that, let me clean you. What this means is that in order to fully utilize the capacity of machine type 1, which is the limiting factor, we need to produce 15,000 units of a Y and 8982 units of X. Okay, great. Now, this is just by the way. Now, this approach that I use in arriving at the shortage at the shortage and the excess here. Someone can also use a different approach like what I'm going to do. So let me share with you a different approach that someone can also use. Okay. Okay, so let me clean here. Great. Now, what is that approach? What is that approach? So let me use this color. Now, instead of going all the way to calculate in minutes, you can go straight and do it in hours. So for X, for product X, we are going to have 12,000 units multiplied by, you see, it's 10 minutes. So it's 10 divided by 60 plus, let me present it to. Yeah. Yeah. Why? I'm recording something that. Oh, okay. Okay, so let me present that again here. Let me present, sorry, let me present that here so that you can see it well. Okay, so in order to find the limiting factor, we need to we can also use a different approach. So machine type 1, machine type 2 rate. Now, the available hours, the available hours was 3,000 here and 4,200 here. Now, instead of going all the way to compute everything in minutes, we can have it in hours. So here for X is 12,000 units. We calculated that the contribution per unit for X here is 0.167, and for Y 15,000 times 0.1, right? So for X, for machine type 2, X is going to be 12,000 times uh 12,000 12,000, so 5 divided by 16. So here is going to be, let me write it well. So here X is 12,000 times 0.08, then Y is equals to 15,000 times 15,000 divided by 0.2. So when you multiply 12,000 by 0.167, okay, so look, I made these 3 decimal places. So I need to also make this one 3 decimal places. So here is 6 divided by 60, and 5 divided by 60, which is 0.083. Okay, so here when we compute, you realize that 12,000 times 0.167, which is 204. Okay, then 15,000 times zero point 0.1, which is 1,500. Now 12,000 times 0.083, which is 996, and 15,000 times 0.2, which is 3,000. Now when you total this total will be in hours. So we have 2,000 plus 1,000, no, 2,004 plus 1,500, giving us 3,504. Remember earlier when we did the computation, it was 3,000, right? So the difference is 4. Difference is 4, which is as a result of the decimal places. Okay, so you take note of that. Then we have 996 plus 3,000, giving us 3,996. Remember earlier when we computed, here was 3,500, sorry. Here was 3,500. So the difference between this and this is only 4. So that is as a result of these decimal places. Okay. that decimal place. Here earlier when we completed it was 4,000. It was 4,000, right? So here the difference between here is also 4. That is as a result of the decimal places. And so you take note. So this is the second approach you can use. Approach you can use, and you follow it with the contribution per unit and the production schedule. Hope you enjoyed the video. Kindly subscribe to the channel and turn on the notification bell. Also share with your friends and leave me a comment where you are watching me from.